Hi, my name is Lauren,
My name is Yami.
and our partner was Saud. This is Chemi 305 Fluid Mechanics at New Mexico State University, spring 2018, and our professor is Dr. Reza Foudazi. In this presentation, we will go over the process of designing a domestic water system. We will go over the analytical work that involves choosing pipe diameter, calculating head loss, and using Bernoulli's equation to calculate head pump. We will then discuss choosing our material, such as pipe, finding the correct fittings for a pathway, and finding a pump. The last step of the process is the cost. We have to find the total cost for every pipe, fitting, and our pump.
Our pipes and head loss are the first step to designing the water system. When choosing the pipe diameter, we had to find a size that would maximize flow rate while minimizing cost. We used a diameter equal to 0.128 meters or 2.5 inches because we believe it creates the perfect compromise between size and efficiency. The friction coefficient we use is based on a smooth PVC material with a value of 0.0119. Next, we calculated our minor loss coefficient by adding up all the coefficients from the fittings for each path. After choosing our diameter and fittings, we used the total head loss formula by converting our given flow rates into velocity. Finally, we chose Excel to carry out all our calculations. Solving the problem. We first set up pathways to each part of the house to make sure we use the correct lengths and minor loss coefficients in our equations. Then we choose our starting and ending points in order to simplify our pressures and velocities. Finally, we arrived at our simplifications and used a Bernoulli equation, added our values for head loss calculated before, and solved for head pump for each step. We then added all the head pumps to find the total height our pump needs to overcome.
Once all of our behind-the-scenes work is done and we can make sure our materials meet our requirements, we start by picking out our materials. For our pipe, we picked out PVC because it was cheap, non-corrosive, and the roughness factor is 0. We found that our fittings must be larger in diameter than the pipes, chosen based on flow direction, and they are also plastic. We also had to take into account our valves and how open they needed to be, and then we had to pick a pump that must overcome the pump head with loss taken into consideration and must support the required flow rate. The next factor was cost. We found that it was more cost efficient to order 11 sets of 20-foot PVC pipe to cut down to size versus buying pipes based on each individual size. The total cost for that came out to $395.89. For our valves, we decided to go with a plastic and metal valve. We need 4 valves that can be altered between fully opened and half open. The total cost for that came out to $178.04. For the pipe fittings, we needed several types of pipe fittings based on flow. We needed several T-fittings, a straight fitting, and a 90-meter bend fitting. All were plastic material. The total cost came out to $83.67. For our pump, we chose it based on horsepower, flow rate, and pump head. The total cost came to about $3,000.
The total cost came to about $4,000 to $5,000 with taxes and shipping of material.
We found that our flow was laminar and well developed further down the pipe.
Our pump is a 3-phase pump system.
In conclusion, this class has given us basic understanding of fluid mechanics and prepared us for real-world applications. Thank you to our professor, Dr. Reza Foudazi, and our TA, Ali Risa.